Hi everyone. Today we're going to learn a bit about soil. If you should need me, my email address is on the screen. It's rcrawford@jcpsmail.org. Here we go. So first off, soil, as you well know, is really just the thin layer of loose material that covers part of the geosphere. So the thickness of soil, when we say it's a thin layer, it can vary. In some places, soil may just be a few inches thick, and in other places, we may find that the soil is a few feet thick. Generally speaking, here where we live, the soil is relatively thin. If we go underneath the soil and we dig down very far at all, we're going to find bedrock. Remember, we've said that our geosphere is mostly composed of solid rock. Earth is a rocky planet. And so that layer of solid rock is called bedrock. So the soil rests on top of the bedrock. When we look at soils, one of the things we're concerned with is the soil's composition. So when we talk about an ideal soil, ideal means perfect. We generally find that it has four ingredients and it has them in these proportions. So the primary component of soil is going to be weathered bits of rocks and minerals. So about 50% of soil is going to be, or 45% of soil is going to be these weathered bits of rocks and minerals. In addition, soil, generally healthy soil, is going to have about 25% liquid water. Of course, liquid water very important for plant growth. Soil also contains a lot of open spaces, which contains air. About 25% of an ideal soil has air. And the final 5% is going to be, 4 or 5%, is going to be something called organic matter. And we're going to talk a bit about what organic matter is as we move through. I do want to point out, not all soils are ideal. You're going to have, depending on, the conditions, you may have soils that have drastically different composition than the ideal soil. Let's first talk about that 45% that is bits of weathered rock and mineral. So soil is made from these tiny pieces. If you've ever looked at soil, you know that inside of there, you're going to have these small bits that look like rock. And those small bits of rock actually come from rock. It's where rock has been weathered and broke down into these smaller and smaller pieces over long periods of time. Of course, we know that weathering is caused by water, by wind, and ice. All of these things can cause rock to weather. Specifically, when we look at soil and we look at these bits of rocks and minerals, we're going to find that we have three basic particle sizes. Let's start out with the largest particle. These are probably words you've heard before. So the largest particles that we find in soil are generally sand. These are our largest, and you can see sand with the naked eye. You don't need anything special to be able to see it. And if we look at this diagram, we can see that this would be roughly the size of a particle of sand if silt was about this size. So silt is smaller than sand. It's kind of in the middle. And to see silt, you would need a magnifying lens. You would not be able to see it with your eye only. And then finally, the last particle size that we have is clay. Clay is the smallest particle. We have a lot of clay in the soil here, and clay can only be seen with a microscope. These are the tiniest particles. And this diagram gives you the relative size of these particles when you compare them to one another. Let's get back to organic matter. So first off, organic matter is any material that is or once was part of a living thing. So this plant, this caterpillar, these leaves were once living, this blade of grass, anything that was living, anything that is living or was once living is considered to be organic matter. We could go on and compare that to inorganic matter. So anything that is not living or never was. So we would say that that is inorganic. Things like rocks and minerals, things like water, things like air, all of those are going to be examples of inorganic matter. Now we know that soil has about 5% of it that is organic matter. So it's bits of Uh, it's going to be soil particles that were once part of something that was alive. Organic matter is going to be broken down over time. These bits of leaves and this grass, as it lays on top of the soil, is going to be broken down by a process called decomposition. So decomposition is maybe not a word you've heard, but it's definitely something you're familiar with. Sometimes you may have heard it called rotting or decaying. And decomposition is just a process where organic matter is broken down into simpler substances. Here we see an apple that over a period of time it has decomposed, right? So what's happening here is it's breaking down into simpler substances. You know, this also happens with animals. So here we have a pig that over time is being broken down. I want you to keep in mind that matter cycles within this Earth system. This is kind of what's happening here, right? We have some matter, and that matter is being recycled. So we know that plants initially turned this apple, it turned some simple molecules like carbon dioxide into this apple, and those were put into some complex food molecules that was passed along in a food chain perhaps. But decomposition is going to take that back. It's going to take those complex food molecules, those complex molecules, and it's going to recycle them. It's going to break them back down into these simple molecules again, where they can be used over and over. So decomposition is where organic matter is broken down into simpler substances. Decomposition is generally and mostly taken care of, or mostly happens um, with the aid of decomposers. Sometimes decomposers are called nature's recyclers. A decomposer is just any organism that gets its food by breaking down the remains of dead plants and animals. So generally speaking, I think it's handy to think of the acronym FBI. And so the FBI is the three major groups of decomposers that live in the soil. The F, of course, stands for fungi. The B stands for bacteria, and the I stands for insects. Of course, we also have other decomposers that live in the soil, things like earthworms, but the FBI turns out to be the biggest groups of decomposers that we have in the soil. I do want to point out that a single tablespoon of soil has millions upon millions of living things in it. Healthy soil is in itself a micro ecosystem, and tons of things live there. Before we move on, I just want to point out that fungi. Sometimes people think of a mushroom as being the fungi, but this part that we normally see the mushroom is not actually the fungi. The fungi is underground, and so you have these white filaments that are underground, and the mushroom itself is kind of like the fruit, much like an apple is for an apple tree. And so the mushroom is the above ground reproductive fruit of the fungi, but the actual fungi itself are these white filaments that live underground. When we talk about soil, we always talk about layers, and soil layers are called horizons. When we have several soil layers, one on top of the other, all together, we call that a soil profile. And so we're going to take a look at a couple of soil layers that turn out to be really important. The first one, and the one on top, is called the organic layer, and it has mostly organic material in it. So this is our top layer of soil. It can have two basic types of things in it. It's going to have surface litter, which is the fresh, recognizable bits of organic matter that have not yet fully decomposed. I want you to think of leaves and like dead organisms or animal droppings that you can see laying on the ground. So it's fresh and it has not yet decomposed. In addition to the surface litter, we also have something called humus. Humus is old and it is completely decomposed. It is no longer recognizable. And so we have the fresh organic matter, which we call surface litter, and we have the old, completely decomposed organic matter, which is called humus. Humus is very important in a soil, and you've undoubtedly seen humus. Humus is these dark bits that you will often find in a soil. And remember, this is heavily decayed matter. The importance of humus, as humus is eventually going to move from the organic layer, and it's going to move down into what we call the topsoil layer, which is the next layer down. Soil in the top two layers is always being mixed by insects and earthworms. And the reason that this humus is important is it keeps the soil from becoming compacted. Remember, we said a healthy soil has has water and it has air in it. Well, for water and air to be in soil, there needs to be empty spaces for them to fill. And so humus creates pores, and these pores are just open spaces for the soil particles to be able to hold air and water. All right, guys, we're going to stop talking about soil for today. I hope you have a great day.